Welcome back. Today our topic will be indices. What is indices? Indices involves numbers that are in exponential or power form. And to start with, we are going to start with the laws of indices for today. So the laws of indices, there are too many laws of indices. The first one is the power law. We state that, for example, that number one, I have a raised to power m multiply by a raised to power n. That this is equal to a when the base are the same, that you should add the powers m plus n. This is multiplicative law. The second one is number two. If I have a raised to power m divided by a raised to power n, that this is equal a raised to power m minus n. This is division law. The third one, we state that anyhow you can arrange it any way you want, but this is how I arrange my own. A raised to power m into n is equal to a raised to power m times n, which is equal to a raised to power m n. That's number three. The fourth one, you can arrange it any way you like. The fourth one, you can say that the fourth one, that a raised to power 0 is equal to 1. This is that anything raised to power 0 is equal to 1. The fifth one, and then that a raised to power minus m equal to 1 over a raised to power m. Number 6, a raised to power 1 over n equal to nth root of a. If I have the seventh one, I can have number 7, a raised to power m over n equal root of n a raised to power m. There are other, you can also have another one in this form. This one is, you can still use it. Number 8, I have a b raised to power m will give me a raised to power m b raised to power m. Now we still have time, so let's try to solve some example. Let's have some example. If, for example, so for example, when for the first example we had from here that a raised to power m multiplying a raised to power n is equal to a raised to power m plus n. For example, for that one we can say that, like say number 1, I, for the first part, if we have 2 raised to power 3 multiplying 2 raised to power 2, that this will give you 2 raised to power 3 plus 2, which is equal to 2 raised to power 5, which will give me 32. Another example in that lovely law, that's the product law, a very powerful equation, that a raised to power n plus that, if for example we have, instead of having these 2 and 3, or we have for 3 raised to power 4 times 3 raised to power 1, that this will give you 3 raised to power 4 plus 1, it will give me 3 raised to power 5. That will give you 2, 4, 3. Number 2, for example, let's say 2i, we have 5 raised to power 6 divided by 5 raised to power 3. That's the second law, which is the product law, that this is equal to, when the base are the same and then they are dividing, that you should pick the one of the base and subtract the powers minus 3. This will give me 5 raised to power 3, which is what? 1, 2, 5. Number 2ii, that, let's take for example, and the example that 4 raised to power 6 divided by 4 raised to power 4, that this is equal to 4 raised to power 6 minus 4. This will give me 4 raised to power 2. This will give me 4 squared, which is 16. Number 3, this says that, for example, no, I made a mistake. So let's say 2 raised to power 2, which is 2 squared. The power is multiplying 3, all raised to power 3. This will give you 2 raised to power 2 multiplying 3. This will give me what? 2 raised to power 6, which is 64. Another one. Okay, let's move to example 4. This one is easy. Example 4, that anything raised to power 0 is 1. Let's take for example 3 raised to power 0, it give you 1. If you also point this in your calculator to give you this answer, let's say this is 3i, and then 4i and 4ii, that, let's take for example, let's say 10 raised to power 0 is equals to 1. Anything raised to power 0 give you 1. Now example 5, with the 5th equation, or the 5th law, not equation. I have number 5i. Say that, let's take for example 4 raised to power minus 2 will give me 1 over 4 raised to power 2, which will give me 1 over 16. And then the other I for number 5, I have, let's take for example, I have 3 raised to power minus 3. This will give me 1 over 3 raised to power 3 cube. So this is 1 over 27. Number 6. Number 6i. Right, I have, for example, 25 raised to the power 1 over 2. That from the law of indices, that's the sixth law, that is going to give you anything raised to the power half is 2. Instead of writing, you can skip this, or you can write it to make it yourself more clear. 25, that's square of 25, which will give you the square root of 25, which is 5. Now another example, if you have 8 raised to the power 1 over 3, this will give you the cube root of 8, which will give me 2. So let's move to example 7. Example 7. Number 7i. Let's take for example, we have 4 raised to the power 3 over 4. This will give me the fourth root of 4 raised to the power 3. This will give me the fourth root of 64, which will give you 2. Number 7i. I have, let's take for another example, I have 27 raised to the power 2 over 3, and this is going to give you cube root of 27 squared. This will give me cube root of 729, which will give you 9. Number 8, which is the last one from the one we did. Number 8, if I have 3 times 2 raised to the power 2, that this will give you 3 raised to the power 2 multiplying 2 raised to the power 2, and this is 3 raised to the power 2 is 3 raised to the power 2 is 9. So this is 9 times 4, which will give you 36. So if you go back to the formulas, or if you go back to the laws, the first and second to the 8th one, you will see that they all correlate. The first one, power law, division law, and the product exponential. So just try to follow the law one by one. If you miss anything, just go back to it, and then you see this one is the power law, this is the division law, this is the power law, this is it's zero index and all that. You see that the examples, I was able to write it accordingly. There is no mixed up. If you love this, share it among your friends, follow for more, subscribe, turn on your notification for more teaching, more tutorials. Thank you.